What is this? Your estimate or your telephone number? Estimate the value of expressions with irrational numbers. Source is the New York Crosswalk Plus, Triumph Learning, and Resource Activities in Math. Getting the idea. Okay, we need to remember that sometimes you may need to estimate the value of an expression that includes an irrational number. How could you do that? An irrational number doesn't end. How will you add, subtract, multiply, or divide them? To do that, estimate the value of the irrational number. Since an irrational number doesn't end, just estimate it. You can round it. Then use that estimate to find the value of the entire expression. After rounding, then you could use it. When estimating the value of an expression that includes pi, it is helpful to remember that pi can be approximated as 3.14, we rounded it to the nearest hundredths, or 22 over 7. Not bad. Some reminders. Expressions versus equations. Number 1, expressions like this is simply an operation, add, subtract, multiply, divide, of certain terms. And check this out. An equation looks alike, but it has the equal sign. This equal sign makes it different from the other. That equal sign makes it an equation. This expression has no equal sign. Another reminder is the order of operations. Don't forget PEMDAS, parentheses first, exponents, multiply or divide or multiply. Then lastly, add, subtract and add, whichever comes first, from left to right. Working with radical numbers, you will see an expression that looks like this. 3 square root of 5. This is called a radical sign. This one is called a radical sign. That means square root. Therefore, that means 3 multiplied by the square root of 5. So, you will have to solve for the square root first. You can use a calculator or you estimate. In today's lesson, we will be estimating. We will not use the calculator. Only then, after getting the value, which was rounded, can you multiply it by pi. Okay. Another reminder, irrational numbers. Numbers that cannot be represented as a simple fraction a over b. And look at the examples. It never repeats and it never ends. The famous ones are square root of 20, the pi, and some combinations, square root of 3 over 2. The dot 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 means, this triple dot means it never ends. It never ends. And there are no patterns. Estimate the value of pi squared. So step 1, write the expression that could be used. Pi squared, that means 3.14 squared. It's not times 2. 3.14 times 3.14. And then now I can multiply. You could use your scrap paper and solve. You will get 9.8596. And in this case, we want to round it to the nearest hundredths. So we use 9.86. And take note, this symbol, like two squeegee lines, is called approximate. Number 2, estimate the value of 2 square root of 7. Let me get my pen. Now, check out square root of 7. We have to deal with this first. And remember your square values. Look at the square values. Square root of 7 is between square root of 4 and square root of 9. Therefore, the result will be between 2 and 3. Remember that, between 2 and 3. So, square root of 7 is between square root of 4 and square root of 9, and the result will be between 2 and 3, as you could see here. 7 is slightly closer to 9 though. Therefore, 7 is slightly closer to 9 than to 4. So the square root of 7 is slightly closer to 3. slightly closer to 3. So what number is between 2 and 3 but closer to 3? So let's try some guesses or estimates. Use guess and check to approximate square root of 7 to the nearest tens. So it said a number between 2 and 3. Let's try 2.6. 2.6 times 2.6 will give me 6.76. And then the next higher number, 2.7 times itself, gets me 7.29. So now, you have to look at this. Which is closer to 7? Which is closer to 7? Okay? So, 2.6 is closer. We'll get a result of 6.76. And this is kind of farther. Not as close as 2.6. So, what will we choose? We will choose this one. Okay? So, use the decimal approximate to estimate the value of the expression. So, the 2 square root of 7, that means 2 times the square root of 7. Remember, we already got the answer. The square root of 7 that we chose is 2.6. That's 2.6. Now you could multiply it by 2 and you get 5.2. A good estimate of 2 square root of 7 is 5.2. Estimate the value of this expression, square root of 43 minus 7 over 11. Now, in this case, let's start with the first one, which is the approximation of the square root. Square root of 43 is between what two square numbers? It's between 49 and 36. Okay, so you know the resulting answer, square root, should be between 6 and 7. 6 point something. 6 point something is the square root of this. How shall we do that? Between 6 and 7, we said, let's make some guess and check. Let's try 6.5. We will get 42.25. Is that close to 43? Okay, let's see. How about 6.6? We'll get 43.56. Is that closer to 43? Yes. So we will use this one because it is closer. So remember, the value of square root of 43, the estimate that we're going to use is 6.5. 7 over 11. How can I make that a decimal? Remember, you will have to just D it. Just divide it. When you divide 7 by 11, you will get a non-terminating decimal, which is 0.63 repeating. So it says, let's just round it to the nearest tens. So we have this value. Again, the value we're going to use will be 0.6. Now we have the first value, 6.6 squared. We have the second value, 0.6. We can now do the final step. We can subtract them. So you could see the subtraction here. 6.6 minus 0.6, and we get an approximate of 6. So that's our answer. Coach example. Approximate the value of pi over 2. Plot a point to represent the value on a number line. So for an estimate for pi, we know it's 3.14. So since it says over 2, that means divided by 2. Do the long division. So that means put up the decimal point, and then you'll get 3 divided by 2 is a 1. Multiply it, you'll get a 2. Subtract these 2, you will get 1. Bring down the other one, and I could get 5 of that. 5 times 2 will be a 10. Subtract again. Subtract again. You will get a 1. Bring down 4. 14 divided by 2 will be 7 times 2 is 14. So I got a 0 remainder. I get a 0 remainder. In that case, 1.57 will be my value for pi divided by 2. Okay? Now I am ready to graph this. If this is 1 and this is 2, so the increments is tenths. This is 1.57. 1.5, right? 1.5 over here. 1.1, 1.2, 1.3, 1.4, 1.5. Where is 1.57? It should be somewhat between 1.5 and 1.6. There you go.